Soundwave pollinator, acoustic pollination system in agriculture application. So what is soundwave pollinator? Did you know buzz pollination is a specialized process where certain plants like tomatoes and chilies rely on specific vibration to release their pollen? So, in this project, we will utilize the principles of resonance and sound wave to mimic the wing vibration of a bumblebee, which typically occur at frequencies between 200 and 400 Hz. By applying these specific frequencies, the system can enhance pollination as an effective alternative instead of using traditional insect or wind-driven methods.
The aims of these projects are to develop a concept that uses bee-like sound vibration to encourage pollination in plants. Second is to mimic the natural buzzing sound of bees using a speaker system to help flowers release pollen. And lastly, to explore sound-based pollination for sustainable farming.
Cut a thin steel rod to your desired length. Steel rod acts as the resonator. It vibrates at specific frequencies to mimic the wing beat of a bee. Use sandpaper to smooth the ends and remove any rust. This ensures better adhesion and prevents injury. Locate the antinodes, the points of maximum displacement in a standing wave. Drill 2 small holes at these points. These will be your attachment points for the megaphone. Antinode holes are used for placement is critical hit.
Arrange 3 wooden sticks into a tripod shape, so it can provide a stable, vibration-isolated base so you aren't losing energy into your hand or the ground. Tie the top of stick tightly with thread and reinforce the joint with a dab of hot glue for a stability. Apply a layer of clay around the joint. This adds mass and helps seal the connection. Use a hot glue gun to position the speaker onto the base of the steel rod. Use super glue at the contact point to ensure a rigid, permanent bond that won't wiggle loose and at high frequency. They ensure the speaker energy moves into the rod rather than just vibrating the air around it. Cut and roll a thin aluminium sheet into a small megaphone shape. Insert the narrow end of the aluminium cone into the hole drilled at the antenna. Secure them firmly with the hot glue. Aluminium megaphone acts as an acoustic transformer. It focuses and amplifies the sound wave toward the flowers enter.
Pair your phone to the Bluetooth speaker. Using a frequency generator app, sweep through the range, typically 200 Hz to 400 Hz for most flowers. Frequency app is used as the controller, allows you to find the resonant frequency of the specific flower species you are targeting. Place a frequency detector or another phone with a mic app at the mouth of the megaphone to ensure that sound is projecting correctly. Bring the device to a buzz-pollinated plant like tomato or eggplant and observe the pollen release.
In this project, we expect that the sound wave pollinator system can successfully stimulate pollination in plants, especially tomato plants. By using a frequency around 300 Hz, which is inspired by the natural wing vibration of bumblebees, the sound waves are able to mimic the buzz pollination. The vibration produced is expected to shake the flower and help release pollen more effectively. This can potentially increase pollination rate and improve fruit production, especially in environments where natural pollinators like bees are limited. However, we also expect that the effectiveness may vary because different plants have different natural frequencies. Therefore, 300 Hz may not work equally well for all types of flowers. During the construction of our model, we encountered several challenges. First, some of the metal components, especially the steel parts, were affected by rust. Even though we tried to remove the rust by rubbing the steel using sandpaper, there was still some remaining rust, especially inside the steel tube. This is important because rust can interfere with vibration transmission and may affect the frequency produced, making the system less efficient. Second, we faced difficulty in constructing the megaphone using aluminium. It was quite challenging to shape the aluminium and maintain accurate measurements, which affected the direction and focus of the sound wave. Lastly, although we use 300 Hz based on the natural frequency of bumblebees, not all plants respond to the same frequency. This means the vibration may not be strong enough to release pollen for certain plants, so further testing and adjustment of frequency is needed. Overall, these challenges show that material condition, construction, accuracy, and correct frequency selection are very important in developing an effective sound-based pollination system.
In conclusion, the project proposes a bee sound system to help plant pollination, and it offers a simple and eco-friendly solution for areas with fewer pollinators. And lastly, it can promote smart and sustainable farming using nature-inspired techniques.